So guys, welcome back to Tronic Synergy. Today we are finalizing on our 8x1 multiplexer. We have already finished all the inputs possible. You can see the IC is quite full, or we have used basically all pins. Yeah, so we have used it entirely, and as we say, this IC 74153 has two multiplexers, one on the top, which head data lines you can see here on the left, A, B, C, D, which were AND gate, OR gate, NAND gate, and NOR gate. Then it has another multiplexer down here, which is the one we have been making recently in our recent videos, which has data lines E, F, G, and H that have kept that we have connected XNOR, not A and not B. So we connected the two multiplexers together using their enable pins, and there's a video for that. I hope you can quite easily get it in that playlist that we have made. You can easily connect those two multiplexers together via their enable pins to make it 8x1 multiplexer. So these are the two enables. So this is the enable of the first multiplexer, this is the enable of the second multiplexer, and then you connect them together by using some two NPN transistors right here, NPN transistors, and a NOT gate. So these are the NPN transistors. They are covered with this resistor. Yeah, these are the two transistors that you're using to connect those two enable pins of the IC. So we have been coming along well. So you can see our last multiplexer, we have already finished it with today's episode being not B. I'm going to demonstrate not B. Yeah, so last time we did not A, and it was at K2 pin number 4 right here. Then we gave it the code 110, and it was doing the inversion of A. So when A was 0, the output was 1, and when A was 1, the output was 0. So today we are going to do our last pin, our last input in our 8x1 multiplexer. It will be not B. Checking there, it will be doing the inversion of B. So the same as just the same as that one for A, only that this one will be B. So when B is 0, it's going to be 1, going to give a 1 output, and when B is 1, it's going to give a 0 output. So that's basically how the operation will do. And as we said, because this is a NOT gate and only has one input, it means that it will only have two possible ways, either 1 or 0. But for the logic gates which have two or more inputs, they'll have couple of possible or couple of configurations that you can get from them. But since it has one input, it only has two configurations, either on or off, 0 or 1. Yes. So the code that we have given it is 111. So we are going to place this 111 in our select line. Then the multiplexer will be doing not B operation only, and not any other operation. So let's do that and check. So this is our circuit. So we place this code 111 in our select line, and we check how it's going to behave. Turn that on. So 111. So that's the code that we have to place in our select line, 111. Then the multiplexer is doing not B operation only. So if you can remember this, we said that this is A, and this other one is B. This is A, and the next one is B. So since B is off, you get a 1 output. As we said, it's going to invert. So when B is 0, we get a 1 output. When B is 1, we get a 0 output. So when we put B1, we expect the LED to turn off. So like that. So when B is 1, we get a 0 output. And the A input does not affect the output, since we are just doing B operation only. The same as that one for A. So let's put not A. This is not B operation, and I think you've already get it. When B is 1, you get a 0. When B is 0, when we turn off B, we get a 1. So that's B operation only. When we go to A, as we did last time, so A operation is 110. So let's place 110 in our select line. Just turn off this other. Just going to turn off this. So 110. So now it's doing A operation. So when A is 0, we get a 1 output. That's what is happening. Then when we put A on, we get a 0 output. When we put A on, we get a 0 output. And B does not affect that output. Why? Because we are just dealing with A operation only. It's just doing, because this code is for A operation only. So when we turn on off A, then the LED is going to turn on like that. So that's how those two you can differentiate them. The other input cannot affect the other one, because the select is choosing a specific function, a specific operation to be done. So that's not B operation, and I hope you have understood how the NOT gate is quite simple as compared to other logic gates. These other logic gates were quite they quite need some understanding, and yeah. But for the inversion, there's just straightforward. It only has two configuration, either on or off. So I think you've understood, and I think yeah, we can continue well. So next up, I'm going to do a run through of all these logic gates. I'm really excited. Like, how cool is this? All these operations are in our multiplexer. It's quite exciting to do all these operations in a single IC. So I'm really excited. Next up, we are going to do a run through of all these logic gates in our multiplexer using these different codes, and we are going to prove that our 8x1 logic unit is functioning properly. So thank you very much, guys, for watching. Please subscribe to Tronic Xynergy, where we do fun stuff all day, all time.